Okay, guys, I thought that I would do a few more examples of just solving, and I'm not going to do the 2-column proof. I'm just going to solve for those that need a few more problems. So let's take a look at this and let's map it out. If I knew the value of x, what would I do as far as order of operations? Well, first we would multiply by 3, then we would subtract 9, and then we would divide by 4, and then we would add 10 to get our answer of 4. So when we undo a problem to solve it, to find what x is, we have to go backwards. So we're going to work our way all the way back until we get to 3 times x. Undoing the 3 times x will be the last thing we do. So the operation that's nearest your variable is always the operation you will undo. So we're going to work backward, and we're going to undo plus 10. So we're going to subtract 10 from both sides. That gives us equals -6. So we undid this. Now we're going to undo the divide by 4 by the inverse operation of multiplying by 4. Again, your goal is to isolate x, so you're trying to get everything removed except the x. So we undid division, and now we have to undo our subtraction by addition. That's going to give us -15. And the last thing we're going to do is undo multiplication by dividing. So our one solution is -5. This is the only number that if we did plug in and do these order of operations, we would get 4 is equal to 4. The left equals the right. Remember, a solution is always what makes your equation a true statement. Okay, let's take a look at this one. If we knew what x was, we would first multiply it by 5. Then we would take the square root, and then we would subtract 12. So let's undo it and go in the opposite order. So let's undo -12 by adding 12 to both sides. Now, to undo something that we took the square root of, we square it. So squaring undoes square rooting, and square rooting undoes squaring. So I'm going to square the left side. I'm going to square the right side. So when you square something, it undoes the square rooting. And then the last thing we need to do is undo the times 5. So we're going to divide by 5. And our one solution is going to be 20. Okay, let's map this out. X is being squared. Then it's being multiplied by 3. And then we're adding 15 to it to give us our 90. So let's work backward. Let's undo plus 15 by subtracting. Then let's undo times 3 by dividing. And then we're going to undo the squared by taking the square root. So if I take the square root to the left, I take the square root to the right. But remember, every perfect square has 2 roots, a positive and negative. So I get x is equal to +5 and -5. These are the 2 answers that will work. If I plugged in and did the order of operations using this list, I would get 90 equals 90, whether it was +5 or -5, because when I square a positive or a negative, we end up with a positive product. Okay, here, before we even talk about what's happening, we need to distribute on the left and the right. And then I see that I'll have variables on the left and the right. So before we write out a plan of action, so let me show you a quick way of how to multiply by a fraction, especially when your denominator divides into the whole numbers. So I always say 4 divides into 12 3 times, and 3x times this 3 is 9x. 4 divides into minus 15 4 times, and 3 times negative 4 is negative 12. Now, you can just write it out to the side if you want and simplify this way. 3 times 3x is 9x, and 1 times 1 is 1, and we don't need the 1 in the denominator. Okay, the same thing for your 16. 4 divides into negative 16, negative 4 times. We have 1's in our denominator, so we're going to have a nice integer. 3 times negative 4 is negative 12 or minus 12. Over here, of course, when we're multiplying by a unit fraction, we're dividing by the denominator. So this gives us 9x plus 12. When we have variables on the left and the right, you first take care of the variables. Do not take care of the constants. So I need to subtract out the 9x and the 9x, and the variables are eliminated, leaving me with a false statement with no variables. Tells me that we have no solution. There is no value that could be plugged in for this x and this x that would make the left side equal the right side. I hope these extra examples helps you out.